My name's Francois and I'm with Hybrid Power Solutions, and today we're going to do some math. So we're going to be taking a look at what the calculation is to size up your solar array. All right. So first thing we're going to want to do is, if you've already hooked up to the grid and you've got your utility bill and you've got the kilowatt hours, this is going to make your life so much easier, because the first part of this calculation is doing exactly that. How much energy do we consume on a daily basis? If you don't have that, if it's a new build, if it's off grid and you don't know what kind of energy you're using, this is where we start off with. So the first thing you're going to need to know is gather information about all your appliances. Really simple. You just write down everything that you are powering with electricity. So that's things like fridge and your water heaters, your air conditioners, whatever it may be, everything that takes electricity, you're going to write that down on a piece of paper. The next step, and we're going to give you an example on this, is you're actually going to calculate over a 24-hour period how much energy is that unit consuming. So what you're going to do is, let's take refrigerator. It's a nice and easy one to do. We're going to take a look at the refrigerator. So I'm just going to write that down on my sheet here, refrigerator, fridge. All right. Now, out of experience, and you can read this off the nameplate, or you can do a quick Google search, the refrigerators take about 250 watts when they're operating the refrigeration system or the compressor. So 250 watts, but they're not operating 24 hours a day, 7 days a week. Remember that compressor is only turning on average, probably 15 minutes or 25% of the time over the day. All right, so 25%. So what we're gonna do is we're gonna write that down. So 250 watts, okay? Then we're gonna multiply it by the amount of time it runs in a 24-hour period, okay? You can also do this where you're doing it hourly, and then you multiply it by 24, so it's up to you. So if you know that it's only running 25% of the day, you can easily do 250 times 0.25, so 25%, and that'll give you the watt hours that you use. And that's a really, really important figure. So 62.5 watt hours. And then you'd go through the list and you do this for all your items. So for example, we can take something like a coffee maker. A coffee maker only runs for 15 minutes, but it takes up a lot of power. So we'll go coffee maker, okay? Write that down. And we'll go, okay, it's a 1500 watt coffee maker. And as I said, I'm just pulling this off because I've read on the side of the nameplates of the device that it takes 1500 watts, but it's only running for 15 minutes in a day. So 15 minutes is a quarter of an hour, so 0.25 of 1 hour. So it's really, really nice and easy. We're gonna do 1500 times 0.25 is 375 watt hours. Okay, great. And you're going to normalize that into a 24-hour period. Now, as I said, this coffee maker, you're only running in the morning, so it's only going to be one-time use. So it's only going to be 375 watt hours. Now, for the fridge, you got to remember, you got to multiply that by 24 hours. So we had our 62.5. We're going to multiply that by 24 hours. So we're going to put it into a day figure. Okay. So 62.5 times 24 hours gets us 1500 watt hours. So our refrigerator is consuming 1500 watt hours, and our coffee maker is consuming 375 watt hours. Okay. Now I'm going to go ahead and just kind of do an average on the remaining stuff, just based on my experience. Most things over, if you average them out, take about 800 watts. So if you do 800 watts times a 24-hour period, you get your watt hours. So the remaining appliances in this example would draw about 19,200 watt hours. Then you add all these devices up. So I would take my 19,200, which is the total of my fictitious example, add it to my coffee maker, which is 375, and then add it to my refrigerator, which is 1500. So that leaves me with 21,075 watt hours. To make my life simple, I'm just going to put it into kilowatts. So that's just kilowatt hours, excuse me. So that's just divided by 1,000. So that gets me roughly 21 kilowatt hours. Awesome. So that's how much energy I need to produce. So then we got to find out how much energy, how much solar time do we have in the day? Like, so how much is the sun actually out for? It's going to vary over the year. Obviously in the summer, in the Northern Hemisphere, you're going to get more solar time than you are in the winter. But to take an average, and you can find these stats online, and you can find the solar hours in your location. For our location here in Toronto, Ontario, and for most of Canada, as a general rule, we use about 4. So 4 hours of the day, you're gonna be your peak maximum production. So that's a really nice, safe bet on doing this calculation. So my 21 kilowatt hours, I gotta produce those in 4 hours. So really easy, take 21, divide by 4. So 21 divided by 4, 5.25. So, and that's 5.25 kilowatts. Okay, hours cancel themselves out, and you get kilowatts. So that means my system has to be 5.25 kilowatts at a minimum. Now, I always take into account inefficiency in the system, and the easy, dirty way of doing that is just to divide the whole thing by 0.8. So a loss of 20%. So divide that by 0.8, and that gets you 6.5625, but let's just round it out to 6.6 kilowatts of solar. So my array size, 6.6 kilowatts. So that's the first thing you need to find. That's going to tell you how big your array is going to be, and then you can use that, and depending on what solar panel you buy, you can go ahead and just see how many panels you actually need, right? So if you need 6.6 and each panel is 300 watts, you would just divide 6,600 by 300, and that would get you the number of solar panels you need. So that's the first thing you want to do. The second thing you're going to want to do is you want to do a gut check on your inverter size. So say you've got things that are, you've got a hot water heater that's going to draw 3,000 watts. Well, hey, you better have a bigger than 3,000 watt inverter in your home, installed in your place. So think about that as well. And you want to add all the things that are going to be turning on at the same time. So you got a hot water heater and you got a dryer, and those are both 3,000. You better have a system at 6,000 watts or more. So that's another thing. It's a really simple gut check on that one. And then you also, the last thing you're going to need, and especially if you're going off grid or you have a backup power system, is going to be how much battery storage do I need to get through to that next 4 hours or that next sunny day, right? Because you got to get from, from basically dusk to dawn, you've got to get that you have to be taking your battery power as your main power for your home. So you got to calculate that. And the way to do that is you have to figure out what's going to be running at night. Same as step 1 in our calculation, you're going to be calculating things. And I, as a general rule of thumb, I take about 20% of our completely daily usage is going to be used at night, not really doing much. You maybe got a load of laundry going or something like that, some minimal things. So if I needed 21 kilowatt hours in a day, let's say I'm using a rule of thumb of 0.2, I would just do 21 times 0.2, and I would need a usable energy in my battery, or usable capacity of about 4.2, say 4 to 5 kilowatt hours. Okay. I always like to go a little bit more on that if I've got the budget, because it allows me to get through days that are not going to be, maybe there's some days that aren't sunny, a lot of them in a row, and I don't want to run my backup generator, especially if I'm off grid. That's going to help out a lot. So I hope the math wasn't too boring on this one. I hope you've learned something. This is a really quick and dirty way of sizing up your solar system, your battery system, and your inverter. Once again, take a look at our description for our contact information. If you've got any questions, feel free to reach out. If you want to take a look at our packages on our solar systems, take a look there. Feel free to like and subscribe. Thank you very much for joining us today. I'll see you next time.